Hey guys, I'm Mr. Hart, and this Livescribe I want to go through the Empire State Building problem we did in class. And so in the scenario, you drop a penny off the Empire State Building. And this is kind of a common myth, and well, not really a myth, but scenario people bring up. Like, if you dropped a penny off the Empire State Building, would it crash into the cement, and would it cause a big huge dent and craters and those types of things? And the simple answer is, well, the air resistance probably slows it down enough that wouldn't happen. But it is interesting to think about, if there was no air resistance, what really would happen to that penny. Okay. By the way, if you've never been to the Empire State Building, it's really cool, but the elevator ride takes a while, as you could imagine. But anyways, you're at the top of the Empire State Building, drop it. It takes 8.8 seconds to hit the ground. We want to use that information to figure out how tall the building is, the change in y, and figure out the final velocity, or in other words, how fast it hits the ground. Okay. So if we're doing this scenario, let's just start with the equation we learned in class, that we know that y equals 1/2 gt squared. Okay, and again, that's just a manipulation of this equation, v naught t plus 1/2 at squared. But we can really simplify it because we know that the change in x is just the change in y, right? It's the total distance traveled. Okay. V naught t goes to 0 if you don't throw the marble or the penny down or anything like that. And then a just goes to g because we know the acceleration is always constant at 9.8. Okay? So if we're just trying to solve for the total distance, we just plug it into this free fall equation. Okay? And that will give us 1/2 times 9.8 meters per second squared times 8.8 seconds squared. Put that through in your calculator. Let's do units first. Seconds squared over seconds squared will cancel out, which will give us meters. That's what we want, because we want a height, right, in meters. 0.5 times 9.8 times 8.8 squared gives us that the total height is, this is probably an overestimate, but maybe not, we'll see, 379.5 meters tall. Okay, I don't know exactly how tall the building is. That could be right, but it seems quite large. But anyways, the point is, we got the distance, we got the height, okay, just by using our simple free fall equation. Okay, now to find the final velocity, we can just use final velocity equals v naught plus gt. Again, same principle as was over here. G just replaces a in the regular equation. V final plus V naught equals AT. Okay, we just replace that with G because we know it's a free fall. Okay, and the acceleration is always the same. Then to find V final, we'll just plug in what we know. So V naught goes to 0 because we didn't throw it down. G is still 9.8, and the time is meters per second squared. The time is 8.8 seconds. Okay, and when we calculate that out, units first, meters over seconds squared times seconds gives us meters per second. That's right, that's the speed, that's the velocity, that's what we want. So we just do 9.8 times 8.8, and that gives us 86.2 meters per second squared, or meters per second. Okay, and that's it. So again, kind of like I said, yeah, that's moving really fast. That would do a lot of damage if the penny wasn't air resistant, right? If there wasn't any air resistance. But usually what happens is, because it's moving very fast, it reaches terminal velocity relatively quickly, and it wouldn't cause as much damage. They still don't like you dropping pennies off the Empire State Building, though, so don't do it. Okay, and there you go. But that's it for this question. Let me know if you have any questions, and thank you for watching.